Okay, welcome to MA Computing. Today we're going to learn how to configure OSPF. Going to set up an area, going to have a router ID for each of the routers involved in the OSPF routing protocol. We're also going to build in redundancy into the network. Okay, so what I mean by that, if one of the routers or switches was to go down on a particular network, then you shouldn't lose access to a whole segment of a network. You should still have a way of routing and getting into that network should one of the routers fail or should one of the switches fail. So on the screen here at the top left hand side, this part of the network has no redundancy built into it. And what I mean by that, if this router was to fail, any computers on this side of the network would not be able to communicate across the networks, because basically this is its only way of gaining access to these other networks which are configured. Now if I was to do the same on this network, I've got PCs on this side of the network. These are both part of the same network, but they're connected to different switches. So if I had 10 computers connected to this switch and 10 computers connected to this switch, and this switch was to go down for whatever reason, we can still use this segment of the network. But if all of these computers were all connected to the same switch and this switch was to go down, that means that the entire network would go down. And the same is true for the routers. So if I'm I don't know, if I'm sending some information from this network over here to the network on the right hand side of the screen over here, and this router was to pack up and for whatever reason, or the power was turned off by accident by somebody, it would mean that this would also be able to still get to that network. And what I mean by that, normally it might go this way across the network when everything's functioning fine. Then this router, all of a sudden the power goes down, it can now go from here from this switch down to this switch across the network, and find a path into the network it's trying to get to. And the same is true when you're coming back the other way. If that switch goes down, only the segments, only the computers on this side, anything attached to this switch would not be able to communicate with one another, but everything else could still communicate with one another. And the same with the switches on this side, the routers here. If one of these routers go down, if this router goes down in particular, this PC here could go from here, from this switch across to this switch, and then find its way to whichever network it wanted to go to. So that's the whole idea behind redundancy. Smaller networks, small businesses normally can't afford to introduce much on the redundancy side of things. Sometimes redundancy can just mean having two power supplies inside a switch or a router. If one of the power supplies or power sources was to go down, then the second power source should kick in. Now if you have got two power sources on a router or a switch, it's always best to put them on a different ring main. And what's what I mean is, when you plug it into the wall, obviously so many sockets will go back to the fuse board, and that fuse board will have a trip switch inside of it, which controls one segment of your power. So in other words, the second power outlet should be plugged into a different socket which goes to a different breaker inside of your fuse box. And that way, if the fuse trips, you've still got power coming to it. If the power supply blows up, then the second power kicks in and everything's fine. Now normally if the power supply breaks and there's enough resistance produced by that failure, the trip switch in the fuse box would normally go off. That doesn't mean it's broken, the actual fuse box. It just means it's a safety feature built in to stop it from causing any problems. Normally in the old days you'd use fuse wire, and that fuse wire would break, whereas with the new modern breakers, things are a lot more efficient. You haven't got to go out and buy some fuse wire at the correct ampage and then have to thread that through and put that back into the fuse box. You just simply click the switch back over and everything should be operational again once you've solved your problem with your power supply on your redundant network. I'm not going to go on too much more about that now. What we're going to do, we're going to start this network up from scratch. it might be worthwhile you taking a print screen of this. So if you just press your print screen on your keyboard, on your laptop you might have to press FN as well, depending. And I can't tell you exactly where it is on your keyboard, but you can just press print screen once you found it, or it'll have PRT-SC wrote on it, and you can just paste that into a word processor or something like that, and then print that off. So you've got you know, the topology, the layout of how we want to configure our network. Okay, obviously I'm going to do this step by step, but sometimes you might get a little bored of me rambling on and how you go about doing this. You might already know how to do this, and by using the topology you can just go ahead and you can just get on with that exercise without me rambling. Okay, you might want to fast forward if you know how to do that to the OSPF process of how to actually configure the routing protocol. Okay, so what we're now going to do, I'm going to remove this network. I'm going to come to File, New. I'm going to say no. I know I've already saved this, so I'm pretty safe and confident with that. Click no. We're now onto a blank screen. Okay, now what I'm firstly going to do, I'm going to get a PC, an end device from down here. I'm going to drag that up here. Then I'm going to get a router, 1841 router. I'm going to put that about there, and I'm going to do the same again. Another router, and so on. And you do the same. When you've got the same amount of routers as me, we should be ready to start configuring the right amount of PCs and switches as well. So 2, 3, 4. So we should have 5 routers. Okay. Now we're going to get a couple of switches. So if you click down to switches here, I'm just going to use a 2950T. It doesn't really matter which one for this exercise. Okay. I'm going to drop a switch there, and I'm going to do the same again over this side of the screen. I'm going to put a switch there and a switch there, and now it's time to put the PCs on screen. So we come down to the PC again. I'm going to put 2 PCs over here, one sort of next to each of the switches, just so you can wire it a little easier. Okay, and I'm going to do the same over here. PC. Now at the moment it looks a bit like a jumbled mess. Now what we're going to have to do is come onto this router here. I'm going to go to where the power button is. I'm going to turn the power button off. I'm going to put a WIC2T controller, which is 2 serial ports in essence, because they're not on them by default. Okay, and you can power that back on just to bring that back. Make sure you power this off before you put the module in, because it won't allow you to do it otherwise. Okay, and then we're going to do exactly the same on this router, WIC2T, power it back on, come back to here. Okay, power off, WIC2 again, power on. And just checking I'm doing this right myself. Okay, by looking at a diagram, because it's a lot to remember. Okay, on this router here, all we need is 1 serial port. You can put a 2-port one in if you wish, but we're only going to be using 1 port. So put on 1T, power it back on. So we've got 1 serial port there, or 1 link as we like to call them. Okay, and on this router here, the same again, just a 1T, because we only need 1 port on this particular network over here. Okay, that's powered on. Now what's left to do is the cabling aspect. Okay, so I'm going to go to the crossover cable first of all for this PC, fast Ethernet down to the router. We're going to go to fast Ethernet 00, and the reason we use a crossover cable because there's no switch involved. Okay, and then we're going to come from the serial DCE link, click there, serial 00, Okay, down to serial 00, and the same again, this time 01. I'm going to come down to serial 000, and again one link from here, serial 001 up to the remaining port there. Okay, and for our redundant link, again serial DCE 00, and we're on to 00 on there as well. Okay, then we're going to come back to the crossover cable, not the crossover cable, straight through cable, sorry, and we're going to connect, let's see what I've did on my diagram, 01 down to 01, and then we're going to come from 00 onto this switch. I'm going to put that down to 01 on the switch port. I'm going to do the same from here. Okay, 00, but I'm going to put that onto 01. Crossover cable, I tend to always use port 24, just so when I come back to doing the switches on there that all my crossover cables are on port 24. Most modern switches don't need to have the crossover cables, but it's something you need to know for the exam. When you come to do the Cisco exam, that you should know, which devices should be interconnected with a crossover cable. Okay, normally PCs, if you're connecting a PC to a PC, that always has to be via a crossover cable as far as I'm aware. There's not a network card with auto sensing on it, but I could well be wrong about that, so please don't quote me on that. Okay, I'm going to come back to straight through cable, fast Ethernet. I'm going to put let's have a look on 02, and I'm going to do the same from here onto 02. Okay, a bit long-winded, I know, but bear with me. Oops. Okay, crossover cable, which I think I've just done on the wrong port, but we'll find out. Doesn't matter, but I'm going to delete that because I can't see which one I attached it to. So crossover cable, port 24 to port 24. Again, this doesn't matter, but as I say, this is just a common practice for me. It's how I do things. Okay, doesn't mean that you have to do it exactly the same. Okay, so I'm going to connect, this 01 off the router down to 01 here. And then I'm going to do the same from this router, from fast 00 to here, and just checking that I've got my ports, how I've got them on my diagram. It's fast 01, and then again straight through from this router from 01 to 00. Okay, and not many more connections to do now, fortunately. Straight through from here, port 2 to this PC, fast Ethernet, and then port 2, fast Ethernet on that PC. Okay, so that's the layout, what we want to achieve, and try to keep the ports in the same order, just purely because it'll be easier when they come to configure the IP addresses. They'll be on the correct ports, and then we're all going to be singing off the same hymn sheet. We don't want to be using different ports because it's just going to confuse matters for yourself. Okay, but obviously once you know what you're doing, you can decide what port to use for what network and so forth and so forth. Okay, so for all intents and purposes, I'm going to break this this exercise down into 3 portions. Okay, so this has been, the first portion is just a setup of the network. We're going to show you which IP addresses are going to be assigned to each of the networks, and that's going to be exercise 1 configured. Then we're going to go on exercise 2. I'm going to configure all of these IP addresses on each of your routers and your workstations, and then finally it'll be the OSPF exercise where we add an OSPF network, the routing protocol, the OSPF, sorry. We'll go on to test and show you how this redundancy works by using various commands. Okay, so what we're going to do now, click over here, and I tend to like to put a place note, so especially when we're doing larger exercises, so we know what's what. First of all, I'm going to put a 192.168.10.2 address onto this PC. Okay, come over to notes again, and for this port 192.168.10.1. okay, now for 000 or 000 as it is on this router, 99.99.99.1, and that's going to be a /30 network. Okay, remember in the 192 networks, each one of those we configured will all be default on a /24. Okay, so that's a default class C network. Okay, we're not trying to save any IP addresses for this exercise. Okay, but for the WAN links we are. Okay, and then we do the same on the other end. So this router attached to this router, this port will be 99.99.99.2 /30. And just move that over a little bit. Then we'll come to 001, and we're going to use 99.99.99.10 /30. Again, for all the WAN links we get, they're all going to be /30 networks, so I'm not going to write that anymore, but just so you know. Okay, and 99.99.99.9, and that's for the 001 port, so I'm putting that next to there. Then we'll come down to 001, and it's 99.99.99.5. And then this port here is going to be 99.99.99.6. And then, although I've only connected this via a fast Ethernet, it's because there's no free T interface, so you can't have free serial ports on this particular router. Okay, so this is still going to be a WAN link from here to here. Okay, and the same on this router from here to here. They're still WAN links, but via a fast Ethernet. Okay, normally that wouldn't be the case, but you can do it that way. Okay, so for fast Ethernet 01, we're going to have a 99.13. Okay, I'm just going to move that in a minute. 99.99.99.14 on this link. Just move these close. So that's on fast Ethernet 01, and this one's on fast Ethernet 01. You can't quite see it because of how packet tracer sort of lays things out, not the best always, but this link here is serial 00, because we've already know that this is 01 because it's straight through. We know that this is a serial link because of the nature of the cable, and if you put your mouse pointer over it, you can see in the diagram there we've got a 000. Okay, serial 000. Okay, so we're going to come to that. And we're going to put a 99.99.99.22 and come to the other end of that port. .21. And then come to here. Sorry, it's just taking me time looking through the route information because I don't want to get it wrong for you. So it's 99.99.99.99 17 for fast Ethernet 0.1 WAN link. Okay. And then 0.0 we're going to do 99.99.99.18. Okay. So we've got that. Right. So for this network here, that's my fault, sorry. We're on the 192.168.11.1. Oops. Remembering that this is just a standard Class C network /24. Okay. Now the IP address of this port is going to be the same because this is for the redundancy purposes. It couldn't be in a different network, otherwise it wouldn't be redundant. Okay. So that port going into this network is also the redundant link. Okay, and now let's see what we have left to do down here. And we're going to have a 192.168.12.1. Again, this is just your normal Class C /24. And this router port here from fast Ethernet 0.0 into this network, again, is the redundant link. We're going to use the same IP address, 12.1 Class C network again. And then the PCs, we'll do the right hand side PCs. We can have a 192.168.11.2 and 192.168.11.3, and then the two PCs down here on the left hand side of the screen, 192.168.12.2 and 192.168.12.3. Okay, now I was just double checking around the screen. I think I've got everything there now. Yes, we've got IP addresses all laid out and ready to be configured for the next exercise. Okay, go to part 2 of OSPF and redundant networks, and thank you for listening. Okay, bye bye.